Okay, welcome to day 2 of the past paper program review. We're starting with question 3, which was overwhelmingly voted by you guys as one that you were not so sure about. In fact, I think 75% of you are not sure about part 2 of question 3. So let's do this one. So at first, probably you're thinking it looks similar to some of the ones we've been doing lately, where we use a right angle triangle to help us understand it. So let's start off by doing it how you probably did do it, which was to set up a right angle triangle, like so, put on an angle, and then we know that it says here that the cosine of theta equals k. The cosine is the same as adjacent over hypotenuse, so to make this work, the adjacent would have to be k, and the hypotenuse would be 1. And so now we have cosine theta equals k over 1, which is the same as k, which is all good. So anyway, we would have gone to, okay, well, let's use that triangle for sine theta. We need to know what the opposite side is. We've got the hypotenuse is 1 and one of the short sides is k. So what we could do is put that as the square root of 1 minus k squared using reverse Pythagoras-y stuff. So then sine theta would be opposite, which is the root of 1 minus k squared over the hypotenuse, and the hypotenuse is just 1. So that would be the answer. Except, of course, you would have looked at the answers and gone, hey, but the answer says negative root of 1 minus k squared, and you would have been confused. And that's because this question asks for the reflex angle. So it's the reflex angle that cosine of theta equals k for. So what's really important at this stage to show you, or to remind you, is this relationship between acute angles and reflex angles. Or sorry, acute and obtuse angles and reflex angles. So let's just really quickly sketch on the side a cosine function, like so. And we know that it goes from 1 to negative 1, and it goes from 0 to, in this case I'll use degrees, so it goes to 360 degrees. And so there's this relationship here, which is that if I put my k across like that, I've got two values on the cosine curve that both equal k. At this point here, which is our angle, that's where the reflex angle is. But over here, I've got a different angle. Let's call it, I don't know, alpha, I don't know, which is a different size but has the same k value. And there's a symmetry there with these two values. They both equal k, but obviously one will be between 180 and 360, and the other will be between 0 and 180. And what you've done by doing this triangle is you've worked out what happens for the relationship when it's an acute or an obtuse angle, but we're after this one here. Okay, so the thing is, how do you go from this answer to this answer here? Well, the trick is to have a look at how this works. So this angle here is the same distance from 0 that way. Ugh, use a different colour. Maybe pink. That way. As this angle here is the same distance, but back from 360. Oh, if you can see that. Okay. So what I could do is take my little diagram here. And so if you imagine this is the distance from 0, moving here from 0 that way, okay, those distances there is the same as going from 360 and moving anti-clockwise that way. So if I go like this and I go down by the same amount there. Okay, so basically I reflect this triangle across the x-axis down that way. Just like you see there's a line of symmetry here where these two values are reflected across from each other. Okay? And what that means is then the answer that we're after is this answer here. So if this answer here is positive here, it's the root of 1 minus k squared. If I reflect it down this way, it's below the x-axis, and so it's a negative value, so it becomes negative root 1 minus k squared. The part B of that one, it's pretty easy because they're asking you for tan theta, and you guys know that tan theta is the same as sine theta over cosine theta, so you can just recycle your answers Well, you know that sine theta from what we've just done before is -1 minus k squared, and cosine theta they gave us originally, which was k. So there you go, that's tan theta. Okay, and let's try part 2, which is the one that you guys had obviously a bit of a freak out with. We basically just have to piece a few things together. First of all is that we need to confirm where this value of theta is. We know it's a reflex angle, and before I was saying what that means, it's between 180 and 360, but we can actually do better than that, because if we look at our cosine function between 0 and, let's say, 360 degrees there, we know that the reflex angle is over here somewhere, between 180 and 360, but we also know that we're looking at it between k being a value between 0 and 1. So we're only looking at the top of that function there, so only this part here. Other thing we know is while the cosine function goes from 1 down to -1, it cuts the axes here at 90 degrees, and it cuts the axes here at 270 degrees. So in fact, if we know we're after a reflex angle, then we actually know that our angle for theta is between 270, where's my pen gone? 270 and 360 degrees. So that's the first thing that you have to sort of ascertain, I suppose, is specifically where that value of theta is. Now, it's called the fourth quadrant because if you think about 360 degrees and you split it into 4 equal parts, it's 90 degrees, 180 degrees, 270 degrees, and then all the way back to 360 degrees. So this is the last, the fourth quadrant. So we have to look at what does sine look like in that quadrant. So if we draw for ourselves a normal sine function like that, going from 0 to 360, that would be y equals sine theta. We know that we're only interested in values for the angle between 270 and 360, so we're only looking at this part here that goes from 270 to 360. And so you can see that in that quadrant for the sine function, it's going to be negative. And then we're actually also looking at, we are looking at sine 2 theta. So what happens to a sine function when the angle's doubled? So when the angle's doubled, it's going to be whatever that sine function looks like between 540 degrees and 720 degrees. Okay, and we know that the sine function has a period of 360 degrees. So if you can imagine this going off into the distance, you're going to find the same thing. So between 540 and 720, it's also going to be negative. And that's all.